Okay. I hope you like presentations about methodological issues and slightly more conceptual papers, because that is also what I'm going to present now. I haven't quite been able to get rid of a jet lag from Singapore all the way here, and I'm also recovering from a little viral infection, almost fully recovered. I'm a little bit tired. If you cannot hear me well at the back, please tell me at some point. This is based on a short paper, an extended abstract that we submitted to WebScience 2012. And the organizers were kind enough to say that, okay, this is kind of an important topic. We think we should include it in the full presentations. I don't have as much detail as I would have liked to have on this topic, but I'm hoping that it will at least make you think about some issues and that it might be a little bit thought-provoking at some point, and maybe a couple of points will be a bit controversial as well. I don't know. This is coming out of joint work. I'm in the Department of Communications and New Media in the National University of Singapore, and my collaborators, Lu Song and Stéphane Bressan, are from the School of Computing. And a lot of what I will talk about has to do about the different disciplines and whether you come more from social science background or from a computer science or related background, and how we tend to approach things in similar but also sometimes very distinct ways. So the topic is about big data. How big is one of the questions sometimes people ponder. I think it depends on the research question, on the methodological assumptions you make, on the discipline also that you're coming from. It's not really purely about the size in terms of bytes. I think an interesting way of thinking about it is when a difference in size becomes actually a difference in kind. When something about the size of the data makes you think differently or makes you have to act differently so as to get to what it is that you're trying to achieve with your study. Now, how is this relevant to web science? Well, I noted the two objectives, if you like, of web science. This is from the call for the conference that are most pertinent to what I'm going to talk about. One is that web science seeks also to analyze human behavior and social interaction using data that is found from social media, online networks, online communities. That means what? It means data that is sourced from the web. It means data that is often maintained by third parties, the data that resides in various databases that often have some moderately or very complex information systems behind them. And then we go and try to collect that one way or another and study it. And another objective, of course, of web science is also to identify and address methodological challenges in analyzing web-based large-scale human interaction and behavior. So that's exactly what I'm interested in and thinking about. And I think there is some overlap, obviously, with the objectives of internet research, or what people call also internet studies, research on computer-mediated communication, digital sociology, and so on. So we have some convergence here. So I'll show a little example which comes out of a study that I will actually present later today in more detail. Which I think illustrates a bit of the power of big data that is sourced from the web, how it can be actually useful. And that's, I think about it a little bit as my message to the more traditional social scientists who are maybe skeptical about going out on the web and collecting data from here and there. They would rather perhaps do a survey, a national survey, as is common in some disciplines. But then I also want to highlight some of the methodological issues with respect to the reliability and validity of such data that we go and grab from the web. And I think in that respect, if you look in the social sciences and also in the natural sciences, you'll see that there is a much more developed tool set and practices and norms about how to assess the quality of the data that they use. And sometimes this is not, I think, taken care of properly in some studies that come more from the web science direction or that come more from a computer science direction, if you like. So this is one way I think about data sets. I think that there is generally often, if you look at different studies, look at different papers that get published, a trade-off between size and depth. There is data sets that have a very large number of cases. If it's people, it will be many people included. For example, sometimes in network science, you'll see some studies which will include really a very large number of thousands or millions of observations. But often, such studies will maybe include very little information per observation. There is some exceptions. There is data sets which are very rich and include many cases as well. But often there is a trade-off. There is also methods which rely more, for example, on interviews, where a person, the researcher, is going to sit down together with a subject and discuss a topic at length, perhaps for an hour, for 2 hours, sometimes perhaps even longer, until the researcher collects enough information and understands really what that person thinks about a particular topic, how they feel, and so on and so forth. This can yield much richer information, but usually is restricted to smaller number of cases. That's what some people would call a small n data set. Right? And if you look at studies on the internet, you will see that they generally fall a bit more in the one or the other category, but it's a bit more difficult to have both breadth and depth in the data that is used. So this is my four-quadrant diagram that I like to use to explain that, saying that most studies, if you put richness on the vertical axis, basically the amount of information you have for every case, and the number of cases that you have on the horizontal axis, then most studies fall in the area of deep, small data, small n, or shallow or shallower, if you like, big data, where you have large n, but not so much information. Perhaps each observation is a node in your network if you're into visualizing networks, for example, and you don't know much more about that person or individual. Of course, you don't want to be down here, right, where the data that you use is both shallow and small. And ideally, perhaps, you would like to be up there. The holy grail being having large and rich data sets that we can use to make sense of interactions, but also understand better the individuals within these larger networks of interactions. Now, if this is a natural trade-off, you might think, why change anything? Why not continue using the data collection methods and analysis methods that we know? Since there's a natural trade-off there, well, the one answer is, of course, that we are getting better at generating and working with larger and richer data sets. And therefore, we're coming closer to that holy grail. But with this, we are increasingly actually relying on machines, computers, and third parties, the parties, for example, that might maintain the data that you collect online in order to get things done. And with this comes some problems. I'll use just an example from a study that I will talk about later today in more depth, where we are looking at how social network sites are used as network publics, meaning spaces for discussion, deliberation, perhaps also mobilization, specifically in the context of protests that happened last year in many countries around the world, and many anti-austerity protests that happened in Europe. And this specific data set is from Greece. Some of you must have been able to tell already that I'm originally Greek, and that is no coincidence. So one of the things we wanted to look at there, we collected lots of data from Facebook and from Twitter with an aim also to compare them, but here I will mention more an example from Facebook. We wanted to look at how people choose on which public Facebook page to have a conversation with respect to the protests that were happening on the streets, because the media was claiming that this is another Facebook thing, or it's another potential Facebook revolution. Okay, there was no revolution eventually. And so if you put Facebook pages on the top, and you put Facebook users at the bottom, and every edge represents a link between a user and a page, meaning that this user has posted at least once on that page. And if I can convince you that these are all the pages that are related to that particular movement, which lasted for a few months actually in Greece in 2011, which was a big anti-austerity movement. What you see from this picture would be that most users post to a page, and they post only to one page. That's what this big red triangle, for example, represents. That was the most popular page. And there are other pages that are relatively popular. The top 5 are colored individually. Those that are gray are the pages that received less attention. There is a sort of long tail of pages that received less attention. But overall, it looks like silos, right? It looks like different groups of users choose different online forums to talk. And it looks like there's very little cross-posting activity between pages. It looks actually, if you think about these as publics, and I can discuss a little bit more later what the concept of publics is in my other presentation. If you think about this as online forums, if you like, it looks like they're not networked really, or barely for that matter. But this is based on a random sample of all edges, which is about 1% of the total, about 726 edges. Now, what I want to point out, for those who are not maybe familiar with that, is that this wouldn't be an untypical sample size for a social science study, depending again on the particular branch of social science that you may be active in. How many are social scientists here? Anybody? Okay, there are some. So a sample of a few hundred up to 1,000 observations wouldn't be considered an untypical sample. And based on that, you would probably reach the conclusion that, well, people just choose a forum, they post there, and there's very little networking across. But what happens as you add more data to that picture? It's still the same set of pages, the same set of users, but we keep adding more data, more observations about who posted where. As you approach, that's 10%, 50%, 80%, and 100%, as you approach 100%, which corresponds to 72,000 edges, and it's more than 800,000 individual posts, you see a much more complex picture, of course, emerging, where you still see that there is large parts. You can see here, for example, there is large parts of users who still only post ever to one page, and they may not post to other pages, but you start seeing a much greater overlap, and the network structure, the fact that there is even a network across the pages, starts becoming more evident. And I think that speaks a lot to the power of large data sets. Of course, I'm maybe not saying something very original. I'm just saying that statistical power increases with sample size. But this, I think, shows how trying to get larger data sets that are out there online does have value. But I haven't said how good that data was. How did I even try to define which pages are relevant to a movement and which are not? How would you even go about doing that? Therefore, defining what you should collect and what you should not. In addition to that, if you try to use, as we did in this particular case, the Facebook API to get all information on who posted on what page, once you have identified the universe of pages that are relevant to you, do you know that the API does not even return all the posts or all the comments that people post in reply to original posts? Do you even know that it returns errors, and that if you repeat the process a few times, there seem to be an almost random sources of error even, or at least error which we cannot characterize and for which we do not have any explanation, probably due to the complexity of the systems underlying what Facebook does. So how can we know that the data is correct that we use? How can we interpret it correctly? And how can we know that the conclusions we reach based on this data will be correct. So for that, I want to compare two common data collection methods: collecting electronic traces by web crawling or similar methods of subject interactions on the internet. This is what we are primarily interested in. Or querying subjects using a survey questionnaire. Why? Because in communications and in other traditions in social science, that is a very common method. And there's a large tradition there, and to some extent, they are better at characterizing the data and checking for data reliability and validity. Now, what I want to stress is that in both cases, there is a need to check for the data collection method reliability and validity, the measurement reliability and validity, because we don't have direct access to meaning. That is maybe obvious sometimes to the social scientists, or it might be obvious to you if I tell you, well, if you survey a person and they answer, right, your survey questions, how do you know that they really interpreted them the way you meant them, right? How do you know whether they were truthful? You have a whole range of issues, right? So you need to make some statistical checks to see whether what you think you're getting is what you're getting from the survey. But computer scientists, and not only computer scientists, tend to assume that what you get from a machine must be true. And what you get from a database is what it is. It's what is in the database, therefore it must be correct. Not everybody does, but I see that often. But there is an ontological mismatch, you know. The ontology, if you like, presented by the research question, or the ontology that the researcher has in their mind, is not the same as the one in the database. And if you think about systems which are complex and have many layers in their architecture, you can have lots of issues. One example, from an older study I did, where there was a field called rating. It was about rating some user-generated content where users could review it. Well, that rating actually looked like it was just values from 1 to 5. But if you really talk to the administrators and those who have been with the community for a longer time, you would find out that they used to use one scale, later they changed to a different scale, later they changed to a yes or no, a like or unlike of the submission, which they then mapped to a scale of 1 to 5. So actually the data that you were getting in the end, you know, was not just one scale from 1 to 5. It was very messy. It went through several stages. And there's also absence of the subject. You know, the subjects of the measurement, the people, if we are observing people, are absent at the time when we actually check the data to see whether it is valid, see whether there's anything strange in the data. And that is true both in the case of collecting electronic traces online and in the case of doing a survey. Although, of course, in a survey, there's some greater direct involvement of the subjects. I noticed that there is often little attention paid to data validation in works that use big data sourced from the web. I think it has also to do with an epistemological mismatch, where social scientists are more used to doing this kind of checks, also because of a greater reliance on what some people call hypothetical deductivism, basically formulating hypotheses from theory and then trying to see whether the hypotheses are supported by the data, versus in information sciences, it is sometimes more common that people adopt, consciously or not, more of a mining approach where they just try to see what the data can tell them about the system they are observing. And I think also because of our faith in machines. We do trust machines, I think, generally more than we trust humans. And we assume, therefore, that the data collected by computers is free of measurement error. And I have quotes from papers published in top journals from very bright people who clearly assume that. So generally, if you look at classic measurement and test theory, what we have in our mind, whether we are very theoretically driven, or whether we do data mining, I think we still have often in our mind some theoretical constructs, some things we would like to see, things we would like to measure, and then see how they interact, perhaps. And we do a measurement. And a measurement will consist of a measure. The measure might have multiple items. That would be an instrument. And we use a method for the measurement. Now, our measurement will deviate a bit from the true scores in the population, the thing that we are really trying to capture. We know that. OK, that is a discipline-neutral example, right? So if you want to measure the cuteness of kittens for some reason, you might try to define then a measure for that. And you might say, well, I think it depends on the shape of the nose, the eyes, and the pose in the photograph. And you might try to create a composite measure based on these. And what could you do then? Well, you could use different methods. If you look up there, you could try to ask experts to rate the kittens, as people would do actually in competitions, right? In contests sometimes. Or you could do a survey and ask a broader audience. Or you could also set up a website and use user-generated content, use basically the reviews that users will post based on the photos, and try based on that data to create composite measure, and again, arrive at some measure of cuteness. In your mind, you have cuteness, right? But whether your measure is a correct, or at least a good proxy for that, you do not know. And this will not be news to a few of you. You need to test the reliability of the measure. And there is 3 basic ways in which you do that. Basically checking whether things which are supposed to measure the same thing, items which are supposed to measure the same thing, like the things we talk about when we talk about cuteness, whether they are strongly correlated with one another. Because you might assume that kittens would actually be cuter along all of these dimensions at once, or statistically that this would be true with large numbers. You would actually repeat maybe the same measurement to see whether you get reliable results across time. Or you might ask actually different people then to do the rating, if people are doing the rating, to see whether they rate them similarly. And that's an interesting example again, because people assume that with software agents, you wouldn't need to do that. But again, if you try to use different software tools to get answers from different online databases, you may realize that they actually return different results. And I wonder how many of us actually do that. But reliability is only part of the story. The other part, and I'm finishing here, is validity. So validity is also relevant because reliability just tells us that we are measuring the same thing over and over again. But is it the thing that we actually want to measure? Is it the construct that we have in our mind? For that, we need to do some validity tests. And these are described in a bit more length in the paper. And I have some examples basically from the Facebook study about how we would actually try to test these things for the data I showed you earlier. But we are in the process of doing that, and we will report that when it's done. I'm sorry for running a little bit over the time. Yes, thank you.
Very much.